Find the equation of the tangent and the normal to the curve y equals x cubed take x at the point 2, 6. I'll start with the tangent. To find the gradient of the tangent, we differentiate the curve, and that will be 3x squared take 1. And if you substitute in the x value at whatever point you like, you will end up with the gradient of the tangent at that point. So at x equals 2, dy dx equals 3 times 2 squared take 1. 3 times 4 is 12. Gradient is 11. So for the tangent, the gradient is 11 and the point is still 2, 6. So I'll use those two pieces of information to find the equation of the tangent. I'll go for y take y1 equals m by x take x1. Y take away the y value. Now the gradient is 11 and we have x take the x value. Expand the bracket. That's 11x take 22. And move the 6 so that we get the y on its own. So negative 22 plus 6 is negative 16. That's the equation of the tangent at the point 2, 6. Now for the normal. If we want the gradient of the normal is perpendicular to the tangent. So the tangent had a gradient of 11. Therefore, well, I'll call that m1. Therefore, the gradient which is perpendicular to that must multiply with it to equal negative 1. So opposite sign and flip it if you think of it as a fraction. 11 over 1 becomes 1 over 11. So the gradient of the normal will be negative 1 over 11, and that's perpendicular. So still the same point, 2, 6, but now for the normal we are using the gradient negative 1/11. And we can combine those to get the equation of the line. Y take 6 is negative 1 over 11 by x take 2. Expand the bracket. Y take 6 is negative x over 11 plus 2 over 11. And move the 6, add 6 to each side. Now 2 11ths plus 6 is plus 6 and 2 11ths. It's a nice quick way to write it down. If you'd prefer it as an improper fraction, that's okay, but please don't use a decimal.